RLC circuits. Now let's try our hand at partially analyzing an RLC circuit. With reference to the figure below, determine numerical values for the quantities listed, include proper units. If you want to stop the video and try this on your own, please do so. Here we go. At time equals 0, when we shut this switch, what do we have happening here? At time equals 0, we know that capacitors act like wires. There's going to be essentially, we can think of a wire right there, and an inductor acts like an insulator. We can think that there's a break in the circuit right there. At that first instant, therefore, the total resistance that the battery will perceive is 4 ohms, and that's it. So I think the current that's going to be going through that 4 ohm resistor is going to be 12 volts divided by 4, so I think it's going to be 3 amps. There won't be any current going through this 6 ohm resistor because remember that inductor acts like an insulator at the first instant. We're going to put a 0 amps right there. The voltage drop across the 4 ohm resistor is going to be 3 times 4, which is 12 volts. The voltage drop across the 6 ohm resistor, well, there's no current through it, so there's no voltage drop across it. The pressure difference, you might say, between the two capacitor plates is 0, and the inductor is fighting back at that first instant with 12 volts of push in that direction. So far, so good. Now, at time equals infinity, what goes on? Well, at time equals infinity, this capacitor is the one that acts like an insulator, and this inductor just acts like a wire. At time equals infinity, essentially all we have going on here is we have current going around this leftmost loop. And how much current will that be? 12 volts divided by 6 ohms of resistance, 2 amps through the 6 ohm resistor, which is this one. But there won't be any going through that 4 ohm resistor. I'm going to put a 0 there. What's the voltage drop across the 4 ohm resistor? Well, if there's no current going through it, then there's no voltage drop across it. How about the voltage drop across the 6 ohm resistor? That's going to be I, which is 2, times R, which is 6, so that's 12. Across the capacitor, if we were to color code this thing at time equals infinity, we would have to say that is all one color, all of this whole thing is that color all the way up to there, and since there is no pressure difference across the 4 ohm resistor, that red color that I'm using at the moment would occur all the way over to there. And I'm not going to draw it in because I would waste your time, but the whole bottom portion of the circuit would be a different color, which tells us what? That the voltage difference, or the pressure difference, or the voltage drop across the 6 ohm resistor, in other words, that color difference is the same color difference as what we have across the capacitor. So this will also be 12. The inductor has fallen asleep.